to the AI Mexico Artificial Intelligence Meetup number 20. Today is January 7th, 2021, and we are hosting this event online while we continue to adapt to COVID-19 and social distancing. My name is Adrian Munguia, and I'm the founder and director of AI Mexico and director of AI Center, Chapter of Mexico. Joining us tonight, as is tradition, is Dr. Francisco Javier Mendieta Jimenez, research scientist at the Electronics and Telecommunications Department at CISESE, founding director of the Mexican Space Agency, member of AI Mexico Executive Advisory Board, and the official AI Mexico event moderator. We have a world-class guest tonight, and I will let Dr. Mendieta introduce him to us. This is Pi and AI Ensenada, and the title of the event is Challenges and Opportunities of AI in Healthcare. This is an event in collaboration with Deep Learning AI. Dr. Mendieta, thank you for joining us. The floor is yours.
Thank you, Adrian. I'm very happy to host you and Dr. Ruben Soenksen from Massachusetts Institute of Technology, a renowned international institution in all the aspects of science and technology. Welcome to this meetup. We are hosting from Ensenada, Baja California, Mexico. And as similar as the last meetups, we have a focal point in this meeting, which is challenges and opportunities of artificial intelligence in healthcare, which is a very important actuality and modern times concern, but also opportunity. If we manage to apply the lessons, techniques, and results and solution of artificial intelligence to this very important activity of the humankind in this trans-pandemic and the future post-pandemic world. We are very happy to host Dr. Luis Soenksen. He's a Mexican. He's a medical device expert. He's a researcher on artificial intelligence and also an entrepreneur at the Massachusetts Institute of Technology and also at Harvard University in the WIS Institute. Today, his curriculum vitae is very impressive. I will, of course, not mention all his achievements and all his future achievements, but let me tell you that we will take us through a journey of only some of the state-of-the-art projects at MIT to illustrate the trends on how to deploy a successful artificial intelligence project ventures in healthcare. He has experience both in the demand side, what people, what the governments, what the society is demanding, but also in the supply side, what are the promises of the technology that can be translated into results, into solutions, and into business in this activity. Okay, Luis, we are really happy. Thank you for your time. We will very interested in learning and listening to your experiences in this very promising field in the developed world, but also a big opportunity in developing countries like Mexico. Please, Luis, go ahead.
Thank you, Javier. Happy to be here. And thank you for your audience. I really do hope that I have some interesting information to share with all of you. So I'm just going to share my screen right now. And please, if people have questions, just put them in the chat or whatever is the platform that you're using, and we'll try to take it from there. And all right, so you should be seeing my screen. Are you seeing my screen?
Yes.
Yes, perfect. All right, I'm going to go presentation mode. So
yes, that's it.
There you go. So if people want to contact me, it's my last name at mit.edu. So as an introduction, I'm a researcher at MIT. I also I'm a research scientist at the Wyss Institute for Bioinspiring Engineering at Harvard. I've been doing medical devices for a long time now. but I got enamored on the topic of artificial intelligence for healthcare in the last few years. And yeah, I will take you through the journey of what I believe is the way of doing these things. Hopefully, it will be useful. So before we start, kind of want to give you a little bit of a glimpse of probably like 95% of the topics that are out there in terms of artificial intelligence in healthcare today. So, and I think this little chart, as simple as it may be, I think it really represents kind of what's out there. So artificial intelligence in healthcare includes everything that is kind of like automated computational systems for improving logistics in healthcare, genomics, remote monitoring and tracking of what is called digital phenotyping. So you see, well, we'll talk about those, but you see a lot of wearables and systems that you wear that require analytics in order to make sense of all this biological data that's collected from you. So that's definitely there in the horizon. Also, the idea of managing medical records better, making online consultations and telemedicine faster and better, more approachable to people. Improvements in medical imaging, things like super resolution or automated analysis of medical images assisted by artificial intelligence. A topic that is in the mind of a lot of people, which is this idea of in vitro diagnostic and drug design assisted by artificial intelligence. As many of you may know, a lot of the approaches for the new COVID-19 vaccines were actually supplied with computational analysis, many of them which were done in MIT through many collaborations that we were part of here. But more generally, I think there's an opportunity, and people have shown that new molecules and new compounds can actually be detected and discovered leveraging pattern recognition using artificial intelligence. And so that in combination with database clinical judgment, so how do you assist doctors in making a better differential diagnosis or a better determination of the different, what's the causes of the different symptoms of a patient? Many of them have been showcased in recent publications. Systems that improve or make easier robotic surgery possible. A lot of advancements in the field of reinforcement learning and others have actually led to robotic arms and other systems, physical systems that are just, better doing certain types of surgeries than actual humans. And so that's very, very exciting. And of course, analysis of pathology and the advent of virtual assistants and virtual nurses, which is a topic that I may talk a little bit about at the end of this presentation. So before we move into much detail, I kind of wanted to, when I thought about doing this presentation, I kind of wanted to, just because the audience is in Mexico, I kind of wanted to debunk a couple of myths and also to bring some definitions of what actually artificial intelligence means, because I think it's actually very important that we go to first principles and basic knowledge before we go deeper. Just so that people understand, like, artificial intelligence is not like a single thing. It's in fact a variety of different statistical and computational methods. And I'm not going to go into detail about like the differences in many of this, but it just suffices to say that it's not a single thing, but rather a aggregation of different methods that try to make sense of data in slightly different ways, some of which share a couple of basic principles, but in reality it's just like a statistics, right? You have different ways of analyzing data, and so you have different artificial intelligence architectures in order to make sense or do inference predictions in different types of data sets. So just to clarify that, but perhaps a little bit more formally, artificial intelligence is something actually pretty new, as you can imagine, but at the same time, it's been in the jargon of scientists for almost 70 years now, or more than 70 years now. From the likes of Alan Turing to others. Artificial intelligence, I want to define it right now, or it's being defined as the engineering of intelligent machines or systems, right? And so when you think about intelligence, right? Intelligence at the end of the day is the ability to interpolate or extrapolate knowledge from the environment. environment can be data, can be other things, but at the end of the day, if you have done a linear regression, in Excel, like if you have plotted a line in Excel to make sense of data, you have done artificial intelligence, right? Because you are abstracting knowledge of data, of your environment that you want to analyze, to model, in order to make predictions. And so, when people think about artificial intelligence, I think many of us kind of think about esoteric mathematics or kind of like computational, like almost ungraspable computational systems, almost like magic, right? Sorcery. But reality is that that's just a misnomer. It's just like artificial intelligence is, statistics and computation together to make sense of data and to create models of the world. And just today, it's becoming even more, pervasive in society, just because we kind of are seeing now the potential of actually making useful things with this. Now, machine learning, it's a type of artificial intelligence. And so you see this Venn diagram here, and machine learning, which kind of, I've seen people kind of use it interchangeably with artificial intelligence, but just to make sure it's clear here, machine learning is a subset of artificial intelligence systems, where in machine learning, you are forcing or making architectures that have the ability to learn from the data without being explicitly programmed. So in other computational systems, you put rules, right? If this is more than this value, then do this or no, right? But see, machine learning is kind of like trying to achieve that same nonlinear function, but without explicitly putting the rules of the game or the rules of the selection process you want to do, just with the data being the only input for learning. And that's the only difference, really. Now, deep learning, which is another term that is important for today's talk, is a subset of machine learning, which again is a subset of artificial intelligence, that is based on a very particular type of of architecture in AI, kind of like in the AI research, called deep neural networks. And deep neural networks, as the name suggests, are systems that are modeled loosely to behave like like the neurons in the brain of humans. And I say loosely because they were invented in around 1970s of how people thought neurons operated. Now we know neurons operate kind of differently to what current artificial neural networks are programmed to do. But deep neural network, the only thing that it means is that it's a machine learning, it's a subset of machine learning architectures that are based on neural networks, on artificial neural networks, and that they are stacked together in deep layers, in many different layers to achieve that level of complexity that the data to understand requires. And just, now machine learning, and again, deep learning as a subset of those, it's actually divided into three main areas, all of which actually have been used in different degrees in healthcare. But the three main flavors that I want to highlight are the supervised machine learning techniques. Supervised machine learning means, you have examples of something. This can be like, skin lesions or cancer in like a chest X-ray. And you have examples of things that are not that thing that you want to classify. And you kind of almost teach a system to recognize images that have the pattern that you want to recognize or not. And it's supervised because you actually label those examples and you tell the computer, this is this class and this is no cancer, right? This is a dog and this is a cat. The other type of machine learning is called unsupervised learning, which sounds kind of more difficult to achieve, but it's really, it's really the problem of how you cluster together, how you group a data set into classes that are uniquely distinguishable within that subset of class. So the problem of how you separate the data from a population into subsegments that make sense clinically, it's a type of unsupervised learning problem. Clustering analysis, dimensionality reduction. Many of you who may have some mathematic background in your belt, have done what is called primary component analysis, which is a fairly common technique to cluster things. it's just a type of unsupervised learning. And then reinforcement learning, which is almost this idea of letting these artificial intelligence systems, many of which can be actually very simple, quite simple, to play in an environment that has realistic rules, to then learn kind of like how to play in that field or how to operate in that field in an optimal way. So many of you have seen many of these systems that now can beat professionals at chess or at Go or in like video games, and those are mostly reinforcement learning artificial intelligence systems, which I believe actually are going to have a lot of really interesting things to achieve in medicine in the future, although not a lot of people have actually used reinforcement learning in medicine. All right, so I'm going to bypass this, but just in the terms of architectures in deep neural networks and deep learning, I want to also reiterate that there is not like a single thing. There is not like a master brain that everyone uses in order to achieve all these different solutions. It's really a data scientist type of job to really figure out the right architecture to use for different problems. And I'm not going to explain about this, but different architectures, depending on the connections that they exhibit, they have different properties like memory, or like capacity to compress information, or capacity to create more universal type of abstractions out of data. And it suffices to say that not single architecture has yet proven to be useful in every single machine learning type of problem. And so it's current an open question about the idea of artificial general intelligence. How is that even going to be achievable in the future, since everything that is practically useful today in medicine and non-medical fields in artificial intelligence, they are all based in different architectures, many of which don't actually share that much among each other. So what is the goal of AI at the end of the day, of like specifically machine learning and specifically in healthcare? Well, what you want to do in artificial intelligence systems is really to try to create a model of reality that then allows you to create predictions or to make sense of the things that you're observing, so that you can classify them or describe it in an accurate way. And if you think about this in mathematical terms, the problem is that you have a certain number of inputs. This can be images, this can be text, this can be voice, this can be whatever, right? Doctors have the information that doctors have in order to make their determination about the patient. And then you are gonna stack a bunch of nonlinear functions, enough of them, to then make those systems abstract that very complex knowledge about the world, here represented as a manifold, as some sort of like mathematical representation of the complexity of that problem. But then the idea is that this plane also represents kind of like the valleys and the hills in this plane actually represent the error of a particular system initialized with different parameters. And so the goal of a machine learning system is to be trained on data to minimize that error for most of the cases of inputs possible to that specific function. And so if you imagine this as like a mathematical type of problem, you may have a bunch of data points which represent patients, and you want to be able to describe those patients. And you can have like a model that is just like a line that kind of describes that patient population potentially. But obviously you see that this fit is better than this fit, right? And so our goal is to have like a model that actually describes the data very well. But see, the problem is that if you overtrain many of these systems, you can get into this like model that is very, very complex. And that actually, if you think about it, this wiggly line here kind of represents better the data than this graph here on top. But if you think about new examples, imagine like now you want to predict on new patients, maybe this wiggle data is unnecessarily complex. And in fact, it may actually run into the error of giving you false values just because it's trying to kind of like abstract complexity that it was just given to noise. And so our task in medicine and artificial intelligence is to try to make systems that can be trained to only fit to the simplest form model that represents the data well and for your specific medical problem. And why is today the day, or why is currently like, AI so much in the news about healthcare and other industries? Well, because there is the perfect storm. Right now, there are like seriously big data sets, both in medicine and non-medical fields, to really think about doing very, very interesting stuff, not only in genetics, but also in clinical care. The wide availability of hardware to actually do this competition was probably impossible 20 years ago, or unfeasible from an economic perspective. A high schooler today, for less than $10, can train a state-of-the-art artificial intelligence system if they have access to a good data set. Just by going to Google Colab or Amazon Web Services. And so that's pretty incredible to me. And the fact that now you don't require to be a computer scientist in order to actually make these models, because you can actually leverage or use many of the APIs, toolboxes, and GitHub repos that are out there for everyone to potentially kind of just use, open source. These three things together just cause the perfect storm for anyone with the right problem to tackle to potentially do something very meaningful. And so now back to our kind of like initial idea is how you go from like 0 to a medical device, or like an artificial intelligence in healthcare system. Well, at the end of the day, it all follows kind of like the same type of techniques for planning medical device design as medical devices, just so that people know. Computational systems and medical software is considered a medical device. And therefore, artificial intelligence, systems of artificial intelligence for healthcare are also considered medical devices. And when I say a medical device, I mean in the exact legal sense of the word. The same way the electrocardiogram monitor in every hospital is considered a medical device, medical software and artificial intelligence systems in healthcare are also considered devices. And because of that determination legal, then the steps of actually developing these systems follows the same type of trend, where in order to create one of these systems, you start by thinking about the problem, the clinical need, performing some basic research and applied research about the specific need, testing different architectures. And then, you have to run through all the different hurdles that people need to go through in order to validate that a specific medical device is safe and effective, which includes, doing your market research, doing feasibility analysis, doing a bunch of different types of prototyping, right? In medical software, you may not necessarily think about physical prototyping, but as you can imagine, many artificial intelligence systems, they cannot work in isolation without the computers to actually run them. And sometimes not even without the devices to actually, present them to the people that are going to use them. And so many of the hardware required to collect the data and to present back the predictions back to the users, those physical devices are also part of the development process, which both require hardware and software development. After that, then it goes preclinical and clinical trials to then lead to pre-commercial and commercial phases of development of these devices. And this is a huge conversation. There's a lot of literature about how to go through those. If people is interested about this whole process, I have a YouTube channel that explains kind of like the different steps in great detail. But at the end of the day, the way I see it is that you start with an idea of how to do something nice and awesome in to improve medical care in patients, which is discovering a nice clinical need. And then you kind of start prototyping technological your system, and then thinking about the regulatory process, right? Like how you ensure safety and efficacy for the people that are going to use this. And then you then start thinking about the economics of that. Like who's going to pay for this? Who's going to actually use it? Is this valuable enough so that it can be so is this valuable enough so that the IMSS or the government of Mexico are actually going to pay for this to happen, right? And then this iterative process of thinking about the clinical need and the technology and the regulatory process and economics kind of starts growing and growing and growing until you have kind of like the right clinical definition with the right technology that is safe enough and affordable enough to actually be implemented in the real world. And that's really the challenge, to transition this and to survive long enough to see this whole process through. In order to achieve this, innovators like you, like the people in this meeting, have to surround yourselves with all these different stakeholders. And so I've never seen a successful project in AI and healthcare that is not done in collaboration with people, with universities and commercial partners and hospitals and medical specialists and software developers and regulatory affairs people. Like, an entrepreneur in isolation, as innovative as that person may be, is not going to be successful unless you surround yourself with the right people to lead you to a successful pathway. And this is the type of stakeholders that you want to surround yourself with. So I'm going to now finish by, again, reiterating that there is a lot of regulation in how to do these things. And AI systems in healthcare are considered medical devices. This is the definition according to the FDA, which I'm not going to go through, but it's a medical device. And that now the FDA, as well as the COFEPRIS in Mexico, they're taking a very deep look at how to regulate systems in machine learning and artificial intelligence, because as you can imagine, many of these computational systems are going to be fundamentally very different to physical devices, where, a needle, if you have a syringe with a needle, you don't have any updates that you can do to that needle, like, real time. Whereas a lot of the promise of many artificial intelligence systems today in medicine is that they, as they see more patients and more data, that they will be able to kind of improve day by day, or, become better as time passes. And that sounds really awesome, but from a regulatory perspective, it's actually a nightmare, or it's actually something very difficult to think about, because how can you ensure quality of a specific output for these systems if they are just gonna potentially improve or not improve over time, just because as the data that you're feeding to them is actually changing internally the behavior of the systems. And so a lot of these conversations are now part of the kind of discussions at the FDA. But the good news is that people is very well aligned on how to do this and how to do this ethically in the right way. Part of the solution for that is to have railroads or guidelines of how to actually validate the systems and then propose the updates for these systems, so that you can ensure that at some level of improvement you have to actually resubmit for approval for these systems, but not within a specific boundaries where it's not necessary, or where it may not make any business sense to do resubmissions for these devices. Now, I wanted to just show you a couple of regulations here that I hope people can screenshot. There is a couple of ISO standards specific for medical devices that people should be aware about if they want to be in this space. But also about some upcoming things, like, for example, many of you may have heard that many machine learning systems and artificial intelligence systems, not only for healthcare but also in healthcare, are kind of considered black boxes in a way. You have inputs and they make predictions, but they don't necessarily explain why those predictions happen. And this is something that is now in the eye of a lot of regulators in Europe, especially. And now European law actually now demands that many of these medical software systems have this right of explainability, as it's called, which then now forces companies to provide means for their systems to explain their interpretations of data. So now you cannot have, at least in Europe, or it's actually very hard to regulate systems that do not provide any degree of explanation about why a prediction is done. And so this is something that people that is interested in the space of machine learning for healthcare needs to be very aware of, because this idea of just training a neural network to run predictions and just show that it's very highly accurate in a testing set is actually not enough anymore. You have to show that, of course, but now you have to be able to provide tools internally to then, if needed, to show why the system, provided that output in a way that is humanly interpretable. And that's a real challenge, but it's very exciting to see that a lot of people have been doing a lot of great strides to do this. To give you a sense, and this is an old slide, there is at least 60 AI-enabled systems today approved by the FDA across all these 9 clinical areas. So including cardiology, psychiatry, endocrinology, radiology, geriatrics, neurology, orthopedics, emergency medicine, ophthalmology, pathology, and oncology. When I say AI-enabled, I don't necessarily mean that it's only software. It could be, for example, a couple of those, and you are going to see one, is, for example, this device called the Cardio from AliveCore. These guys actually partner eventually with Apple. But AliveCore actually got a 510K clearance, which is just like 510K is just a document that you submit for doing what is called a substantial equivalence submission for the FDA. And what they provided was this combination of a hardware device with like a software application with artificial intelligence. And what they have is basically a 2-lead. They have other things, but the thing that got them in the map is this 2-lead electrocardiogram that basically was intended for tracking, kind of like people at risk of atrial fibrillation. But then after collecting a bunch of data, they realized that just by having this 2-lead ECG, that they can actually were able to predict the level of sodium of like the molecule, right? Like a sodium in blood, which is actually quite clinically relevant for many cardiological diseases. But it's as of today, the previous only way of actually obtaining that was like a blood draw. Like you have to extract blood and then run like an actual sodium analysis. And so being able to actually predict the level of sodium of someone non-invasively just by looking at the ECG and changes of that over time, it's actually a really nice thing to add. And that was only enabled by artificial neural networks that were running kind of like in this system. And so just wanted to let you know about this interesting example. And then, of course, I want to show you one that is, kind of like we're doing at MIT. And this may feel common to some of you because, it's kind of, AI in dermatology it's a lot old story now, but I think we have a good new take on it. So for the last maybe 5 or 6 years, there have been a lot of people talking about, making dermatological analysis easier using artificial intelligence. And so the standard of care today in artificial intelligence for dermatology was you have a picture of a single lesion, like something like a mole or something, and you pass it through convolutional neural networks similar to the ones used for detecting dogs or cats or clocks or cars, and fine-tune those systems in order to kind of like detect different features that were associated with malignancy, for detection of skin cancer, for example, in a very similar way to how like birds and other animals can like recognize patterns in their environment. And this is kind of like old, but the fault of all these systems is that they only see one lesion at a time. See, like you required as a system, like the system was built so to receive one single image of a single thing that you were concerned about as a patient or as a doctor, and then run the analysis. And that sounds kind of fine until you realize that doctors actually don't do that. What doctors do, and this is what at MIT would have been building, is systems that not only look at a single thing at a time, but look at the entirety of the body of someone to actually make the determination. Because that's actually what humans do and what doctors do. And this is actually quite important because what we discovered, and we're the first ones to discover this, is that turns out that the doctors, the way many dermatologists actually look for cancer is by looking at suspicious lesions, they call them, which is almost like looking at what are the things in the back of someone that are salient to them, that just like pop in their mind. Like, they see the whole back, that patient has 100 different lesions. What are the things that just like, kind of like, attract their attention? And so we basically built a system that emulated that attention mechanism that humans have, that clinicians have, and then describe that mathematically as a metric of dissimilarity and saliency in a multidimensional space that we compressed. In this case, through a process called t-SNE. But what is very interesting about this is that we are now going into the realm of like really observing what the clinician does and try to really emulate with these systems what the clinician is actually doing without even noticing that they are doing. And this is the type of things that we're thinking about at MIT, and passing these type of systems through the process of medical device innovation that I showed you before, to actually lead them all the way through clinical trials and to use. And in fact, this is the core technology of a new company that we have launched called Medical, that has an app now, and that is already seeing patients. And so it's really exciting that we just launched in the last 2 months or so. So yeah, I think it's I'm open now to questions, and perhaps it took a long time, but I hope this is useful for everyone.
Thank you, Luis. It's really fantastic and really exciting. Of course, your achievements, your vision, you and your group, of course, and your institution, but also the environment, the ecosystem that is being created around these potentialities. And the first, I would say, obliged question is before and after. Now I would like to say we are managing to overcome these pandemics. I am always optimistic. Of course, that could be a time constant from days to months in that spectrum. But anyways, there's a before and an after. And this pandemic has motivated and has created many scenarios. And my first question is both from the demand side. The health is demanding many things about the hardware, software, etc. And also the supply side has been generating solutions. I would say a solution in quest of a problem. Yep, maybe I am a little bit exaggerated, but how do you perceive this change of paradigms, if I can say, between the pre-pandemics and the post-pandemics, that is really demanding new solution, but also the opportunities of science, software, cloud, big data are ready to create much more solutions from the supply side. What will be your perception about this change of paradigms due to the pandemics, if there is any? I suppose yes. Open your microphone, please.
Yes, so I think there's definitely a lot of changes. So I may look for this slide, but I have this slide where the whole world of data scientists mobilized, once COVID, started and it became big. Like, I think every single company, every data science company wanted to do something. Google, Facebook, Twitter, everyone. And let's stop presenting. So every single institution that I know of, related to computation or not, or like companies, they wanted to do something about COVID-19. And so what happened is that, more fundamentally in artificial intelligence, I think it was a very nice social and research experiment to see, okay, there is all this hype on AI, and there is some data, and so can we actually accelerate something going forward? And unfortunately, I think through this pandemic, we actually recognize that we were not at all prepared, also from an AI perspective and computational perspective. But because we realized we were not prepared, I think now many institutions now realize the things that need to happen before the next pandemic happen. And so a big change that I have seen is in the last 6 months or so, there is more open data initiatives in the world around sharing data and genomics data, but also like epidemiological data. In the last 6 months, there are more initiatives being formed than in the last 30 years. And so now more than ever, everyone is sharing data, actionable data, so that people can potentially use it. And so that's huge. The second thing is that I think data scientists became as a profession. I think many machine learning professionals, I think they became more aware that they could actually have impact in something that they didn't expect potentially they could have an effect, like the lives of people. And so, I think in the mind of many computer scientists, they didn't thought they could like save a life of someone. But now it's being very clear that if you create a good system for contact tracing or good predictive analytics of when the next outbreak is going to happen, like you could like literally save millions of lives. And I think that's spawning a new generation of computer scientist professionals that now realize how much good to the world they can do if they funnel their attention to the right clinical problems. And I think, doctors were, for a long time, in my experience, they were looking for people that were like computer scientists and engineers that were kind of like looking for that. But there was this disconnect, and I think the pandemic has brought that into the light. And now I definitely, every single major in computer science that I see now at MIT, they don't think only about like like NP or P problems, like in computation, right? Like they don't think about only cryptography. Like they think about, okay, can I use this for COVID, or can I use this for like this clinical problem, or for an application? And I think that happened before, but it's happened way more than ever because of COVID. So those are the two big changes that I see: data sharing and mindset of professionals towards application of their field. Mm-hmm.
Yeah, of course, the world has changed, and the supply and demand are experiencing a redefinition of paradigms with a lot of new opportunities for this new world. My second concern is about the methods of AI and machine learning and all other stuff related to both basic science and engineering realizations required for healthcare. My question, and given that I am not a specialist, but is there a particularly specialty in the methods, techniques, devices, or algorithmic used for the applications in healthcare, or you could just plainly apply the already known, the even the public domain or general techniques. My concern is, given that in general healthcare impacts on the not only the life but even in the well-being, in the health, and so on. What are the main, I would say, caveats or the main differentiators, for example, from machine learning for computer vision for autonomous vehicles, or for security or for games, or for image processing for agricultural domain? What will be your perception? My question is, given that it's very promising field for entrepreneurship, and the developing countries like Mexico must position in several niche opportunity. I am looking for this niche, but I am also assessing the complications and the difficulties to enter this niche.
Yeah.
You understand?
Yeah. I think you have there are a couple of questions. So let me attack them one by one. So the first is, do I think the next revolution or value on AI in healthcare can be brought only by novel algorithms or something that needs to be created like brand new, or can we use out of the box, kind of like cookie cutter already developed technologies to solve really big problems? I actually think there are space for both. I know for a fact that if people detected the right problems, current systems already develop like literally some code that you can like download now in a very well curated data set, like could be used today to serve a lot of people in the right way. The issue is that in order to do that, you need to have access to really high quality data sets. Like, so today's already developed type of systems, they require highly curated data sets with large quantities. So I think it's, if you are in Mexico and you have access, or you know people in hospitals or in academic and medical institutions, if you do the right partnerships to integrate data sets at scale, and you find yourself surrounded with the right clinical support people that really tell you this is the thing that we need to solve today in Mexico City because whatever, and we have like the data of 30 million people about this. I can tell you that as any engineer in Mexico with the right mindset and a little, kind of like a little disposition for this, could potentially solve those problems with like already developed code and systems. Now, what those problems are, we can discuss that, very thoroughly, but there are many. Now, the other subset is the thing that is not resolved in artificial intelligence in general, but that is particularly important in AI for healthcare is actually three things. The first problem is interpretability. And so I talked a little bit about the interpretability, but interpretability is kind of an ill-defined notion because something that is interpretable to me may not be interpretable to you. But I think fundamentally, the idea of making systems that can at some level transmit knowledge back to us in a way that we can easily understand, or like the average human can easily understand, it's a not a well solved problem. I think people is kind of like working there, but it's not well solved, I think. So that's a type of, if someone were to work on that type of thing, will have like an effect on the whole subset of kind of like solutions in AI. Now, the second is that I think is very relevant for healthcare is this idea of federated or distributed learning. So for people that is not familiar with these terms, federated learning means how can you train a system without actually centralizing the data. So imagine, and Google does this all the time. I don't know if you have noticed that if you have an Android phone, you start typing something in your chat, and then over time, the predictive system that anticipates the words that you're going to write kind of become better over time. So like when you write like a word, there is like an auto-completion thing. And for some systems, the auto-completion becomes better the more you use it, right? But if you think about how those work, it means that the phone is in a way learning from your usage, right? But what ends up happening actually from Google perspective is that the learning that every single Android phone have on all these people typing, actually at some point every month during the updates gets updated back to a single model that then re-updates all the models in all the phones. That thing is called federated or distributed learning, which means that you can actually have systems that improve over time without actually sharing any data, any actual data to Google, back to Google. Basically, and I think this is very relevant for healthcare because hospitals don't want to share data to centralize data because that would mean privacy breach for many of the data of people. And so clinical data is so important and so private that we need to find ways to actually train systems effectively without actually having the need for medical institutions to have to get that data out of their secure systems inside the hospital. And so at MIT, we're also working on these type of problems where instead of asking people to gather data into a centralized location to train a model, we now create models that jump from institution to institution to learn at one hospital, and they jump to another hospital and so on to make that happen. And so I'm very excited about that, about the idea of distributed federated learning. And the third aspect that I'm really excited about is the idea of artificial general intelligence and meta learning. It's called learning to learn. So the true revolution in artificial intelligence, I think, is going to come in a few years when you have systems that can take different types of data, so not only images or not only text, but can take like a variety of different types of inputs. So text, images, a combination of both, a video, audio, and that same systems kind of interprets those inputs and tries to make sense of that almost in a symbolic way. So an image is not going to be only like an input of pixels, like now it's represented in these systems, but rather you're going to funnel the image, and the system is going to interpret what that image is, but then it could interpret the same thing if a text described that image. And so this is going to be very powerful, because that's exactly what we do, humans, and what doctors do. And so the moment that those systems come into place where like you can have a variety of different types of input, then I think we are going to be able to achieve at scale a lot of the same type of accuracies that many doctors have, which in my mind will bring scale and access. It's going to be a revolution as fundamental as fire, because you can now think about giving access to this super high-end doctor that there's only like, 2 or 3 in the world that can describe this like disease, but now to everyone at scale, right? Because it only takes one event to train the system, and then it's forever alive. And so I'm very excited about those. Now, I want to finish your question by saying about the caveats. So I'm in this field, and I'm very excited about AI in healthcare. But as of today, I want to say to your audience that there is no single system, artificial intelligence systems in healthcare that has actually proved to improve clinical outcomes in a randomized prospective clinical trial, which means it's all about like we are demonstrating a lot of value of these systems retrospectively. Like we have a data set, we split it, we kind of shuffle it, and then we say, oh, is this accurate, right? But accuracy should not be measured that way. Accuracy is measured prospectively, right? It's like, did I landed on the moon or not? It's not that like, you build a rocket and you say, well, we built it just like, these other 3 rockets, but like, that's not a metric of success. The metric of success is this new rocket actually going to land in it, right? And so I think it's really bad to say this, but it's the reality. There is zero system today that has actually proven to change, patient outcomes. And when I say outcomes, it means something like life or death, or like, someone lives 10 years more, whatever, because of the use of an artificial intelligence systems in healthcare. And so I think that's it may be, I don't know, I think it's very important that people recognize that, because I'm sick of people kind of like going to the hype and looking at the news and say, oh, artificial intelligence is gonna like revolutionize and solve everything. I think it will, but it hasn't. And so we have to actually do a whole bunch of work in order to do that, in order for that to happen.
Yeah, fantastic. Then there's a lot of research, a lot of proof of concept, and also a lot of investment to be done in order to capitalize all these promises of this new technique, especially now that society is observing very closely what technologies, what algorithmics, what systems, what devices will be used for many things, for improve their life, for saving their lives, or even for a better interaction with the environment in this new world. But it's not only the pandemics, it's the global change and many other both physical and psychological environments that we will be developing in. We have a question from the audience, but I will first pass the floor to Adrian, because I am watching his corporeal expressions, and I am sure he has a question to ask to you, more in the technical algorithmic domain. And I will come back with the questions from the audience.
Okay, I need to phrase this question algorithmically. Okay, so the fact that we're not, maybe FDA versus COFEPRIS, which is the hardest or the easiest or more convenient place for a startup to innovate in the medical field?
Yeah, so I think it's yeah, my recommendation is that if you're in Mexico, try to prepare yourself as if you were doing an FDA submission. Like don't like to be honest, it's a waste of time and kind of stupid for an entrepreneur in Mexico to kind of like prepare for a COFEPRIS submission. If you think your device has a place elsewhere in the world, just plan yourself to go to FDA. The COFEPRIS is actually harmonized with the FDA, meaning if you have FDA clearance or approval, like depending on the process that you do, you get automatic approval in Mexico. So like, now, and it's actually equally costly. So I worked in this company, one of the very few companies at the time that were doing medical device development in Mexico. It's called Alandra Medical. And we actually did we had like 6 successful projects, 3 of which went through regulatory process and 2 which got regulatory approval. And I can tell you that, we were preparing as going to the FDA because that's just the way, honestly, if you prepare to the FDA, you are gonna go above and beyond what the COFEPRIS asks you for. And the nice part about that, although it's tough at the beginning, is that the rest of the world is kind of harmonized also with the FDA. So not in the same way as Mexico, but like, if you meet FDA standards, you will meet the standards for like 85% of the countries in the world. So yeah.
Interesting. So what do you say about people trying to say analyze images that for a cancer diagnostics or whatever? People have to understand that you have to see the slide. The pathologist has to see the slide in front of them, right, to make a diagnosis. So I used to work for Leica Biosystems, and they that was a challenging thing for me to propose algorithms for things that I knew were not going to fly, right? I mean, because you have to have the pathologist looking at the slide. So
yeah, if I may kind of you may ask me again the question, like if I don't get it correctly, but to me it's all about how you define what you want your AI to do. So from a regulatory perspective, the innovators, your audience has to be really, really careful about what you say you want to do the AI to do. One thing is to actually do a diagnosis completely. One thing is to say, my AI is going to be, or this automated system is going to do diagnosis. That basically means legally that you want to substitute a doctor, right? So the whole liability of the interaction goes to the system and therefore the creators of the system. And so if you kill someone because you didn't diagnose that thing correctly, then it's your fault as a company, right? The other thing is like, most companies, what I see is that they label their systems as decision support systems, for example, which means that they kind give information to the doctor so that the doctor can kind of do a better, more informed decision, but where the decision ultimately is responsibility of the doctor. So decision support. But now the FDA is taking more closely look at those two, because most people that want to do full diagnosis they are trying to call themselves the decision support just so that the FDA kind of doesn't question them too much. So there is even like a less clinically relevant category, which is like the well, there are many, but like wellness, or just as an information generation system or something like that that can actually provide the same information to doctors, but doesn't doesn't legally have that same sort of responsibility. What I say to your audience is, you have to just carefully, strategically, with a business mind, think about what you want to say you do. But if you really want to just do diagnosis because that's the issue, that there are not enough doctors, or that there cannot be a doctor in front of that person in order to do that thing, then, I mean, man, just be bold enough, and sorry for my jargon, but have the balls to just do it, and, have them, I mean, the Elon Musks of the world, they don't come across because they want to, do things halfway, right? My my suggestion to your audience is define what you want to do clearly to you. Find strategically what makes sense to you most as a company. But if your company actually wants to do that thing that you want to call it, like, diagnosis, or actually like treating something using these computational systems, I mean, just do it, but expect that you're going to have a long road that is going to require that level of effort economically. So you are going to have to also find the right economic partners to lead you to that direction. And I know that in Mexico, that's a huge deal, because money in Mexico doesn't run the same way as in the US or other places, right? It's you talk about billions here, like, or like, companies here, like biotech companies here raise $1 billion or like whatever. In Mexico, you're lucky if you get like $1 million, right? And so I understand when people is kind of concerned about that, but I think Mexico need to have like this change of mentality, and just like risk it boldly, ethically, to do things, kind of like, the things that you really want to achieve, and not necessarily only just play the system, which many companies do in this space, I have to say.
Absolutely. Very important remarks about your experience and the sort of vision of the caveats. Thank you. So many times we don't want to mention the caveats, but that's very important to have in mind. We have several questions from the audience. I will read only two of them because we are running out of time in order to start closing. Manuel Martinez says, excellent presentation, Ruben. I would like to enrich the meeting with a question. What's your perception of the medical community about the potential of AI?
Yeah, I think it is split in three groups. I think there is a good third, especially younger doctors, that are very, very excited about the potential of AI. I think it's like there's truly a section of early adopters that just understand that it's just the future and it's kind of inevitable. I'm not going to talk about those. Those are the easy ones to there is the other spectrum. There is the usually older people, but not necessarily. It's just people that may think their job is at risk somehow, that they are going to be substituted for many of these systems, and the thing is that many of them may be, but you have, kind of like, I say a good third is very skeptical, and with very good reason, about many of these systems. And the only thing that I want to say about these people is that you should not, like, I think it's responsibility of us as a community, the AI Mexico and general AI community, to really hear them closely. So like, you have to listen to these people because they have very legit concerns about these systems. And I think many technologists like me and others kind of like, we just like, whatever, late adopters, no, like, this AI, the concept of AI is so fundamental, so transformational, that if we don't bring these people together, like hear them, we are going to lose something very important, because their conversations, if you really hear them about, is about clinical efficacy, but also about, what is the actual value of these systems, in the context of actual clinical care, and around the ethics of using this. Many systems today in AI are training data sets that are inherently biased because they were collected in people, that are not, that basically had access to healthcare. And so imagine that now you have a system that you want to implement in the general population, and there is a lot of like indigenous populations that never go to the hospital, and so you don't get nothing about them, right? And so, and just efficacy, if you think about how much time and effort and money making one of these systems actually takes, and even pollution, I think there was this report about Google, like one single model of like, one model takes the same, training one of the image recognition models that Google uses, for a lot of things. It actually takes the whole energy consumption of Switzerland of a week. Like training one of these systems, takes like the entire like consumption of a country of electricity to train, right? And so then and don't even think about the money, right? And so now the question is, one of these doctors would say like, okay, just give me that money. I need vaccines, or like I need bandages, right? It's like is actually cost effective. So that third, there is could be thought of late adopters. Just hear them, because they have very legit concerns about the use of these technologies and why they are useful or not useful. And so we have to hear them to develop for them. And the middle one is just people that is undecided. And I think we need just to educate those to make them conscious about the possibilities and the caveats, and then they will make their mind. Usually these people just stay kind of wait to see, and are usually excited. So that's why I'm positive about this field, because I think 2/3 is easily convincible that this is the future. But we really need to take a look at that other third, because they actually may have a lot to say that is really worth hearing about.
Yeah, absolutely. The more conversations, the more interactions in this very multidisciplinary, complex technology, and also the economic aspects, together with the ethical, in order to have a smooth incorporation, transition, or step by step. Edgar Torres is asking you, which difficulties or hurdles have been the most common in your experience implementing AI in healthcare and get approvals from regulatory organizations?
Yeah, it's hard to say, because I think that really depends a lot on the project. So the first hurdle specifically in AI for healthcare, I can tell you that is aggregation of a good data set. So like this is even before regulatory. Well, it kind of is embedded into there, because sometimes you can scrape the internet, and sometimes you can kind of like compile from open source data sets to create your own data set. But most of the times, in order to do something really unique and novel, you need to actually make your own mini clinical trial to gather data. And that requires approval from like ethics committees and kind of like the hospital and all that stuff. That's not FDA, it's just like the entities that kind of like regulate those types of events. So that's the first hurdle, like getting a good quality, sizable data set to train your systems. First hurdle. I think that's actually the most common of every single AI in healthcare project that I've seen. And it's a major hurdle. Like the moment you have a good data set, you're like, the evaluation of your project kind of like skyrockets, okay? Now, the second is actually doing a clinical validation that actually proves at some level what you want to prove. And so that's, again, not a regulatory hurdle. It's a hurdle of making the partnership with hospitals and the partnership with doctors in order to actually make that happen. And this is a hurdle because it's actually quite costly too. In the US, actually, in Mexico, it's illegal to pay patients, but in other places in the world, you actually do pay. and the hospital has its costs, and kind of like and hospitals are not willing to necessarily just give you data for anything, right? Like many hospitals are actually for-profit corporations, so they want to make money. Some of them are public institutions, but in any case, I think the main concern is about privacy. How do you ensure that you collect data in a way that is actually going to be fair and safe and with informed consent for the patient? And that just takes a lot of time. And honestly, a little bit of wit and knowledge about how to do these things effectively, and to have the right partnerships. I've seen brilliant people, brilliant engineers that just never do any projects because somehow they just don't have the contacts with the hospitals and the doctors to actually get those data sets that they need. And it's a shame because it's brilliant people that just are not well connected. But the people like me, if you contact me and you have a really great idea or you're brilliant, like I can, I've made a vocation of myself to really connect people with the right clinical people to really make things happen, as long as you're a brilliant engineer. So yeah, those are the main hurdles. And the third, I think it's just about once you have the data set and once you prove that you are clinically meaningful, so that you can actually do something like that, The third hurdle is to get money, the class of money, the kind of money that is going to actually take you to the next level, to like be a company or like a thing that actually can be used for by enough number of people. And those are hurdles with very different types of very different types of skills are required. Getting investment money or grant money is a very different skill to like collecting a data set or making a clinical trial. And so that's why you have to surround yourself with a lot of people that just like to do that type of stuff that you don't necessarily like to do that much, and then focus yourself on the things that you really, really do want to do. Those are the three hurdles: data set gathering, clinical testing, and funding.
Thank you. That's the trilogy of the developer. Yeah. But I think the scenario is fantastic. Your conversation has been excellent. There are many things that we will like to continue talking, but for this meetup, unfortunately, we have to close now. But I and AI Mexico will be keeping contact with you, your team, your vision, and also sharing our development with you and your people. That will be excellent for us. And again, I thank you very much for your time, for your passion, and for your commitment, both for the technology and for the applications for the well-being of humankind in the health care. Now we have to close. I thank you very much. I thank all the audience. I pass the floor to Adrian in order to express the final remarks of this spectacular meetup with such a very qualified specialist from this renowned institution in the world. Thank you, Luis Ruben Soenksen. Please, Adrian,
Thank you,
your
Luis
final
Ruben.
remarks.
Thank you, Dr. Mendieta. Finally, I'd just like to mention that we will be working as AI Center chapter of Mexico with our team of AI Center in Gothenburg, Sweden, and partners in Mexico on effective AI policy that maximizes the benefits of AI in our communities, and also as the coordinating institution of the IA 2030 AMX Coalition for 2021-2022. We will be working on accelerating the development of the AI ecosystem of Mexico for a resilient region that is prepared for the future. In the month, this month, we will continue a strong collaboration with the Secretariat of Economy with a set of data science challenges around COVID-19. This is related to the Data Mexico program. Data Mexico is a platform to explore, visualize, compare, and download Mexican data. Thank you, Luis Godoy Rueda and Ana Berta Cruz Martinez, General Director of the Secretariat of Economy and Senior Data Scientist at the Secretariat of Economy, respectively, for the opportunity to collaborate. We welcome companies and individuals willing to sponsor prizes for the winners of these data science challenges. We thank Carlos Alfonso Ruiz Guido, who was actually in one of our last meetups, head of the School of Mathematics Bourbaki, for sponsoring prizes for the last data science challenge winners, who were Daniela Jimenez Lara and Raquel Yunen Badillo Salas. The prize was a 6-week specialization course in data science. Companies in our network can also sponsor virtual internships for the winners on a real world project. Our good friend Kwame Asiedu, CIO of BrainToy from Calgary, Alberta, Canada, has already offered an internship for the next winners. We also hold workshops. We will also be holding a workshop with BrainToy for AI in manufacturing, so stay tuned to that. We welcome individuals and organizations from around the world to partner with AI Mexico in helping us drive AI for industry, government, education, health, and all aspects of our lives to create successful businesses, a competitive national industry, a healthier society, and bring opportunities to our communities. AI Mexico has many positions available for volunteers to get involved, as well as positions that will soon turn into paid positions. They all require a serious commitment, and we welcome all qualified individuals to join, regardless of where they're from, not just because diversity is important to us, but because we need all the help that we can get. Thank you, everybody, for joining us this night. Thank you again, Dr. Luis Ruben and Dr. Mendieta, for for joining this meetup, and we'll talk to you guys next month. Thank you so much.
Goodbye. Thank you.
Thank you. Keep in touch.